Hi, everyone. Thanks for joining us in yet another session. And this one is very interesting session wherein Subramanian is going to talk about selling security to developers, an XSS-based war story approach. And this is a really nice one. So I will let Subramanian talk about more and I'll give him the stage. Over to you, Subramanian. I'm going.
Hello and welcome to this talk on selling security to developers in XSS vast story based approach. In this talk, I list out some key principles with an XSS based examples wherever possible and applicable. So let's get started right away. So just a quick introduction about me. My name is Subramanian and I do DevSecOps scale SaaS company in India. I am a passive bug bounty hunter, CS generalist, and a mock addict. So, what do I do for a living? So, my job description roughly translates this. I convince developers that a vulnerability is a vulnerability. I also convince developers that a best practice is also a vulnerability. I do not have experience in breaking crypto systems. I am not part of the Google Hall of Fame yet, or I do not have any rigorous certifications on my name. So, this talk is primarily aimed at organizations that are taking the baby steps in DevSecOps cycle. This is aimed at security evangelists who couldn't effectively sell security to the developer community or to their management. This is for the people who want to build security first culture in their organization. This is for anyone who feels it is not necessarily all OWASP material should have technical rigor. This talk doesn't have any technical rigor, but this talk is all about building the mental model in building a security first culture inside your organization. Security is indeed a shared responsibility, and humans are the weakest links in this cybersecurity cycle. No matter how patched your systems are or you updated your systems are, all it takes is a human mistake that could drive you out of your business. Security isn't a single big thing, it is a million small things. Make sure everyone in your organization buys that. So, how do we build a security first mindset in an organization? So, I'll explain this with certain principles one at a time. So, the first one is show things, just don't say. All talk and no action make developers a dull boy. Prioritize. Don't push everything to the developers on day one. Share failure stories, not only the success ones. Decentralize. Don't own everything. Show real vulnerabilities to developers, toy ones. Last things last, defense in depth approach is not a sole way to rely. Prepare for the worst, zero trust, classes and objects, educate and don't scare. These are the principles which are the key things of this talk. As I said earlier, wherever applicable, we will explain these principles with an XSS example. However, these principles apply for all vulnerabilities and XSS is just used as a war story example. So the first principle is show things, just don't say. So whenever a security evangelist or a security engineer likes to demonstrate an XSS vulnerability to a developer, what he or she primarily does is show an alert pop-up in an application. So what the security engineer trying to convey here is there is a potential JavaScript injection possible in the application, but this is not the right way to demonstrate an XSS, at least when your organization is taking baby steps in DevSecOps cycle. Rather, it is better to show the real impact of XSS or any vulnerability for that matter. So, in case of an XSS, what is the potential risk or the impact when there are no secure flags set on your session cookies? You already know an account takeover is the real impact. So, in case your session cookies do not have secure flags enabled already, demonstrate an account takeover to your developers. This will show the priority and severity of an XSS live in an application. But what if the cookies have secure flags enabled already? So the next thing you have to do is identify the most critical endpoint in your application. What is the most supercritical thing in your application? Is it a super admin change request that transfers the ownership of your account to someone else? Or is the one that could leak your creepy chat conversation? Identify what is the most supercritical business use case or endpoint in your application. What would you do with this? So, XSS is JavaScript injection, and you could invoke this request and you could invoke this request and developer. It will help people and bosses identify the real impact, and it will also show them what's at stake when you have an XSS live on your application. The stakeholders should know worst case risks of common classes of vulnerabilities. Rather, I should say at least common classes of vulnerabilities. The main reason, one of the main reasons security is in the top priority at the orgs is people do not know what's at stake. So just show things, don't just say. The second principle we're going to look at is prioritize. Both developer and security teams must understand that every security issue isn't P0. Effectively classify and prioritize risk. Don't push every vulnerability or every potential vulnerability in day one itself. There should be a mechanism to classify and prioritize risks. Forcefully selling security or anything for that matter causes disengagement. So, what would be the priority for an SQL injection? For an SQL injection, it is not uncommon when you expect developers to fix it before they breathe next time. But is it the same priority for self XSS? Definitely not. You could allow developers to commit the fix whenever their commit graph is very bad. Whenever they are not very actively contributing to repositories, they could do this. But they must do this because self XSS is out of scope only for external vulnerability rewards program and not for the developers. Another main thing is sharing the failure stories. Don't just blindly train people on how to fix a class of vulnerability. Fixing or patching security issues is not just about using the correct library or like saying this library should not be used. People should understand the thought process, why some solution works and why some solution don't work. Show developers what works and what doesn't. There are two approaches here. Say you for an XSS issue, you are asking your developers to encode wherever the places your tool reports. You could have an awesome list of SaaS, DAST, or IAST tools which reports potential XSS expect your developers to encode whatever the tool reports. Here, there's no active engagement for the developers. And the second thing is there might be false positives in your tool where developer need not encode, and it is also the case your tool misses something. So there's no concrete engagement for the developers here, and it is not a good approach to follow. The second approach goes something like this. The security engineer introduces an XSS in an application where it is executing and asks developers to fix it. The developers thank the security engineer for notifying this, and he says, cool, I've removed event listeners, so my application is free from XSS now. You being awesome security engineer shows the developer that this is not the only payload to consider and throw this random payload to the developer. The developer understands that event listener removal isn't enough to fix an XSS issue. He says he is filtering JavaScript URIs in addition to removing event listeners in user-driven HTML content. Now, okay, still you are not satisfied and you are throwing a data scheme error. So the developer now understands like this kind of blacklisting doesn't work. So he has to use a standard filter or a standard encoding library, which is a whitelist based thing. In addition to this, the developer, an active developer, also tries to identify what the standard library is doing and also checks whether it is for yourselves. Give those security champions all the data, results, frameworks, exploits, whatever they need. But just don't be the super boss. Security isn't specific for the CISO. It is for every people at every level. Everyone has to contribute to improve the security posture of the organization. The next principle we're gonna look at is showing real vulnerabilities. For training purposes, it is better to show vulnerabilities in your application than in a purpose-built insecure app. Why is it so? Because the developer could relate to their own application much than the insecure custom-built application. This creates better engagement in developers. So, what if your app doesn't have a local file inclusion, or at least you don't know there is one? So, should how should you create a demo for developers? Just create one. Just open up a local file inclusion, of course not in the production environment but in your staging environment. Just get the file name from the request parameter and pass it around your file streams to create a local file inclusion in your staging environments and show the demo in there. So I introduce developers to all kinds of vulnerabilities in as possible in your own application than in a purpose-built insecure application. Show real vulnerabilities. The next principle is prepare for the worst actors and prepare for the worst attacks. So there are known and unknown attacks. It is security is not about maintaining and reviewing a set of certain security checklist. Attacks are growing day by day, so you should be able to respond and protect yourself against unknown attacks as well. Be prepared for the worst case scenarios and be prepared against the worst actors. One example for this is doing rigorous input validation even if you have source level patches in place. Say, for example, for XSS, you have contextually encoded all user driven inputs but still maintaining a rigorous input validation practice could help you to in some extent against defending against unknown attacks. For example, if we have an email parameter where email ID is getting passed, Why should you allow all characters or all special characters to be passed through those params? Just place a email ID, regular expression, and so just allow contextual input into your application wherever possible. This could help in some unknown attack cases. Start a zero trust mindset in your developers. Don't trust the code that anyone wrote, possibly yours too, the second time. Scrutinize every third party applications you use, every user input, every integration data. Do SEA for the third party applications for any known CVEs, update your applications to your recent versions. Train people to look these data sources as tainted data points. Data from this other third-party sources cannot be trusted at all. So help developers develop a mental model within themselves to look these data sources as tainted data points. So whenever these tainted data points goes into a set of sinks, there should be some kind of neutralization. Say, for example, if get parameter is a tainted data source and print writer is a data sink. So whenever there's a data flow between the source and sink, they should be neutralized. For XSS specific case, they should be contextually encoded. So developers should be able to identify tainted data points themselves. Classes and objects, oops, instances. Help people fix class of vulnerabilities, not just instance of vulnerabilities. So in case of XSS, it is technically not possible, however big your security team is, to pinpoint every parameter that might be possibly open to XSS attacks or for any other vulnerabilities. So train developers to identify the all instance of vulnerabilities given you train them on a class of vulnerabilities. Say, for example, train developers on various kinds of XSS attacks like reflected, persistent, blind XSS attacks, and also train them to identify it themselves by building a mental model. Of course, for the developers to actively do this, you have to improve the security tooling so that people can group similar issues. Once you find a tainted data source and data sink, it should be rather obvious. That will help developers identify and eliminate risks based on the classes. The next principle we gonna look at is educate, don't scare. Explain people about complete life cycle of a vulnerability. So what do I mean by a complete life cycle of a vulnerability? It is detection, exploitation, and patching. How did you find there is an XSS here? How did you find there is a local file inclusion here? What is the worst thing an attacker could do with a potential XSS or a potential remote code execution? What is the exploitation scenario for this vulnerability? What what is the proper way to patch this vulnerability and make sure this vulnerability doesn't surface again on the code base? So this is all about the life cycle of vulnerability. So expect people or train people to know something about all stages in a vulnerability life cycle, not just in detection, not just in exploitation, or not just in patching. It is not enough if developers just align to one stage of a vulnerability life cycle. Only if people know how a vulnerability is detected, then they could detect it themselves when the issue of similar pattern goes to protection the next time. So involve people, involve developers or all stakeholders throughout the vulnerability life cycle and not just on specific things. Of course, security is better breached when breached, but it is not about exploiting every single vulnerability that is out there on your application to the maximum extent. It is you could exploit the issues for introducing people to the class of vulnerabilities and showing the worst possible impact this vulnerability could do to an application, but it is not useful to exploit every XSS to an account takeover. So security is better breached when breached, but patched when enjoyed. Make people enjoy security. Don't scare them with technical jargons, with terminologies, with tech standards and all, but just make sure everyone understands the security and they do it with enjoyment. So, last things last is a principle itself. Don't introduce defense in depth techniques in very beginning and solely rely on that to protect your application. What do I mean by defense in depth techniques here? For a cross-site scripting, content security policy could be considered as a defense in depth technique for a image parsing or a PDF generation endpoints. Segregating your application server from these servers could be considered as a defense in depth technique. But can we just rely on those defense in depth techniques? It turns out we shouldn't solely rely on that and introduce what these things only at a very later stage of your security DevSecOps cycle. And you should not solely rely on DevSecOps cycle with your defense in depth techniques. So that's it with the principle would be useful to build a security first developer mindset in your organization. I wish everyone happy DevSecOps, stay safe, stay home.
Thank you so much, Subramanian, for sharing the wonderful insights. I'm sure people enjoyed it. Thank you, and thanks to our sponsor, Sneak, and have a great day. We'll see you all at the last talk. Thank you. Thank you so much. See you.